To review on what we just did from last week, we went over vocabulary terms and important information about dashed lines and solid lines. Dashed lines are for less than or equal, or sorry, not equal, greater than. Solid lines are for less than or equal to or greater than or equal to. And to properly shade, the less than or less than or equal to is always shaded below, the greater than and the greater than equal to are always shaded above. So in the example we have below, you have one equation in red, y equals greater than or equal to 2x minus 3. And the other one is y is less than or equal to negative 1.25x plus 2.5. So here we have the shaded region, okay, that's in between those two. So for some reason, we're going to graph these two because there's something wrong with the way this graph is shown. Okay. Now, first thing that they did was they put the inequalities into slope-intercept form. So instead of the equal sign, they have an inequality there because that's what we're studying right now. So let's actually take a look at it on Desmos. So y. Now, when you have this open on Desmos, if the keypad is not open, just press the keypad, and here we go. Is less than or equal to negative 1.25x plus 2.5. So that's my graph. I can change the color of this. Whoops. And then the second graph is y is greater than negative 2x minus 3. Now, the shaded region that they're looking at is actually here, where the two regions intersect. So you have the one in red, you have the one in blue, and notice you have the one where it has both blue and red together. We're looking at this region right here. So for some odd reason, the graph shows the region down here, which is incorrect. So I have to go ahead and fix the notes on that in a bit. So this is the actual correct drawing. I'm going to go ahead and draw on this real quick. Actually, I may make it different here. From here and from here, what's in black, what I did right here, is the actual region that they're looking at. This is the actual shaded area. This is where all your solutions lie on this system. Okay? Not down here, up here. So that's the first mistake on the notes. I will correct that. Okay? Now, if you're writing this down, great. So that way it helps you to learn. I am right now recording this so that you guys have a video of this to look at later on. So I'm going to clear my drawings. I'm going to go back over here. So the next part we're going to take a look at is example 1, graph the system of inequalities here. So again, it's already written for you in a semi-standard form. Like the first one here, all I have to do is divide by 3. Oops. So if I divide by 3, y is greater than or equal to x divided by 3 plus 6. And if I do this one here, I just go ahead and take the 2x over here and move it over to the other side by subtracting it. So y is greater than negative 2x minus 5. So if I graph this one in red, and I'm going to graph this one in blue, what I'm circling is the y-intercept of both of those equations. So here's my 0 mark, and I count up 1, 2, 3, 4, 5, 6. And the other one is negative 5. So 1, 2, 3, 4, 5. That's where this line crosses. Then for the red graph, I take a look at the slope. This says x over 3. This is really saying 1/3 x. So that means I go up 1, and to the right 3 for the next point. And I can kind of go in the reverse direction to go behind this point, go down 1 over 3 for another point. So I actually draw a line through here, and that's my first curve. First line, right? That's y greater than or equal to x over 3 plus 6. That's what this one is. For the blue one, I look at this and I say, okay, this is negative 2x minus 5. So I know I need to go down 2 over 1. So I'm going to go down 2, then over 1, and that's my next point. I can reverse direction, go up 2 to the left 1, and that's my point behind it to create a nice line. So this one's going to be a little bit trickier to draw, but my line looks like this. It's dashed. Here, going down this way. Now, this line is y is greater than negative 2x minus 5. This line is y is greater than or equal to x over 3 plus 6. So that means I shade everything above this line, this direction. So here's my shading for this guy. That's shading above, right? Then for the blue one, I shade above it as well. So I shade here. If I keep shading, now all of a sudden I'm into the shaded area over here. So notice where both the blue and the red are connecting together. This is my region right here. This whole area is my region. So I'm going to go ahead and let's see here. I'm trying to create a line here. So in a sense, this whole area right here is my shaded area. So this is where my solutions lie. So any point any point here is okay. Not here, not here, not here, only in this point. So what I'm going to do is I'm going to go ahead and show this on Desmos real quick. Move this over here for right now. And we're going to go ahead and write down the equation as the way it was written. 3y is, I believe, greater than or equal to x plus 6. And the other one is 2x plus y is greater than -5. Okay, I made one mistake. On earlier, I forgot to divide the 6 by 3, so that's why it's over here at 2. Okay, so now it looks a lot different. It's still above here. Okay? So when I actually need to go back to this real quick, what this should actually say is x plus 2. I'm really sorry, guys. That's my fault. X plus 2. So this is where it's crossing here at x plus 2. This is where it's crossing over here. For some reason, why I put -5? I have no idea why I did that. Was it -5 before? It wasn't -5. I'm sorry. There it is. Okay. And so here, this is, I'm kind of drawing this here. Like, noticing here, I'm not touching the dashed line because I cannot include points on the dashed line. But on the solid line, I'm going to go ahead and border my region right on top of it. Okay, so as close as I could get, on this guy, like this. See, I'm going to be right on top of the dashed line, but not on it. I'm going to be like right next to it. As close as I could get right there. This is my shaded region that I can include all points here. So solid line means I can include it. Dashed line means I can't. Anything in the shaded region, perfect. So a good point to choose, for example, I can easily choose this point right here, which is, which is 0, 6. That's a good point. I can choose this point right here, which is 0, 2. I can choose this point right, say right here, which is easier to see. This is 6, 4. But I cannot choose, say, this point right here. I can't choose that, no. This point here, for example, would read -3, 1. Because although it may be on a solid line, it also lands on top of the dashed line, and they can't do that. So these are all good points right here inside here, but this is a very unique situation right here. Okay, I'm gonna give it a moment here. I'm gonna pause. So let's graph these points, -5, 1. Let's do this one. Okay, -5 is right. X is at -5, and then going up to 1. Here we are. That's -5, comma 1. The 1's right here. Is this a solution? So my question to you guys, is this a solution? Here it is one more time. I'm graphing this guy right here on this graph. The graph came up, this is where it's at, -5, 1. Is this a solution to our graph? No, it's not. Correct. It's not. Because it's outside, right? Again, I'm going to go ahead and draw the shaded region one more time. Like right here. This is, I'm just doing this, touching the line, right? Oops. And right on top of this. So we all know that anywhere here is fine, and on the bottom line here is okay. So no, this is not a good. This is not a solution. Cross it out. How about -2, 4? Let's go ahead and graph that. -2, 1, 2. I'm gonna go over 4. Sorry, I'm sorry. 1, 2, -2, and up 4. 1, 2, 3, 4. Here it is. Is this a solution? Yes. So good. Check. Solution. Next one, 3, 3. 1, 2, 3, up 3. 1, 2, 3. Here it is. Right on the actual graph, on second graph right here. 3, 3. Is that a solution? Yes, that's right. That's a solution. Next one, 2, -1. So 1, 2, down -1. 2, comma, -1. Is that a solution? Okay. Now this is the tricky one, guys. Thank you, Bailey. No. It's a solution only for this guy, but not a solution for this one. It has to be only in the shaded region for both. That's the key, guys. It has to be in a shaded region for both. If it was asking for only the second equation, Adriana, Mia, you guys would be correct. But since it has to satisfy both of them, it has to be inside here. Okay? So this is not a solution. So let's try one more time. -4, 3. 1. Here's -4 going up 3. 1, 2, 3. All right, think carefully, guys. Is this a solution? No, it's not. It's on a dashed line, number one, which cannot be a solution. Number two, although it looks like it's on the region, it's on a dashed line. So this is not a solution. Does this make sense now, guys? Or at least a little bit? Because we can do the next one real quick before we go. Okay, so let's do one more, and this time we'll just go ahead and graph it here one more time. And let's practice doing it on your calculator too. So you should have this open. We're going to graph these two equations. The first one is negative 2x plus 3y is less than negative 3. The other one is just x is less than 3. Okay? Now, notice where the two lines meet up. They meet up right here. So the two shaded regions are right here. Okay, two shaded regions are right here. That's what I'm looking at. So again, I'm not going to touch the dashed line, guys. Watch. I'm just drawing everything slightly right underneath the dashed lines. See that? I'm like right next to the dashed line, but I'm not on top of it because I cannot include points on the dashed line. You gotta remember that. The dashed lines, I cannot include the points on it. I can only include the points in the shaded region only. So my shaded area is all right here. All this shaded area within this border. Okay, pretty much there. So let's take a look at our points. -2, -1. So -1, -2, -1. This should be an easy one. Is this going to be a solution? This should be easy for everybody. No. Does everybody agree with Adriana? I need everyone to please take a look at this. No. No. Okay. Aaron, Damien, everybody else, Brianna. I hope you guys see this. This is not a solution easily because it's way outside the lines. It's not, and it's not even on the line. It's not even in here. So you can easily see this is not a solution. Now, again, like I said, these are two dashed lines right here because of the inequalities. So a little side note again, a little review. Not a solution. So the next one, 1, -2. Going over 1 down to -2. This is 1, comma, -2. Is this a solution? Yes, it is. Because why? It's in the region. It's safe. It's a safe thing to see. Up, I'm in the shaded area. Perfect. I'm not even on the line. I'm just in the shaded area. That's an easy sign. Right. Next one. 3, 1. 1, 2, 3, 1. Well, it's just like this one, huh? It's outside the shaded region. So obviously not a solution, right? Next one, 2, -5. 1, 2, down, -5. 1, 2, 3. Oh, sorry. So 1, well, I messed up here a little bit just because the increment's a little bit different here. This is where it's at. This is 1, -2. The other one's 2, -5. Here's 2 going down to -5. -5 is right here. Guys, can we all agree that this is a solution? Yes or no? Yes, because it's all in that shaded region, right? Right, all in the shaded region. So yes, this is a solution. And the last one, 3, 5. Here's 3 going all the way up over here. Obviously, here's 3, and 5 is like way up here. Here it is, right on the dashed line. And also, it's like out of the region. So 2 no's. Obviously, on the dashed line, automatically not a solution. And then second, it's outside of the shaded region, so not a solution. So you only have these 2 that were solutions to the system. That's it. Okay, I'm gonna go ahead and stop sharing.